Hi everyone, this is Bobby Harris with the Utility Broadband Alliance. As you are all getting logged in, I'm going to hold just a moment to be sure that everybody has a chance to get logged in before we start with our webinar. So I appreciate all of you being on early. It's about 1 minute after the hour, and I'm going to hold just another minute or two to be sure that everyone gets logged in that needs to. So bear with us just a moment. You'll all be in listen-only mode, as the recording said. We are going to save time at the end, I think, for some questions, but there's a tool on the GoToWebinar tool where you type in your questions, and if you will, be as clear as possible on the questions that you have, because we'll be reading them just as you write them. So do that for us. Also, if you will, if we don't get to your question, we will try to follow up afterwards. Sometimes we run out of time with so many questions. So that could be a good thing also. We are recording this webinar as always, and we'll share that with our members afterwards and also on the website. And okay, we are about 2 after the hour. Still getting a lot of people logged in. And so I will just remind everyone that I'm Bobby Harris, the Executive Director of the Utility Broadband Alliance, and we are a young utility trade association, 501c6, but we are growing all the time. If you go to ubba.com, you'll be able to see who our members are and what's going on with our 5 working groups. You'll also be able to look at our events. We have a great one coming up just 4 months from now in October in Costa Mesa as we do our 2nd annual UBBA Summit and Plug Fest, and that is underway. So we'll talk more about that later on perhaps. Okay, we are about 3 after the hour, and out of respect for everyone's time, it's my pleasure to turn this webinar over to the sponsors and our great speakers for the day from Ericsson. I'm going to turn it over to Steve Lowe, and Steve, I'm going to ask you to introduce yourself and our topic, and then we can turn it to Ken and let him introduce himself. So thank you very much, Steve and Ericsson, for sponsoring this informative webinar.
Sure, thanks, Bobby, and good afternoon, everyone. As Bobby said, I'm Steve Lowe. I'm the sales director with Ericsson, focused on the enabling of private LTE networks for utilities. I began my professional career with American Electric Power, which I worked for 10 years in the design and planning of distribution circuits, and worked with AT&T over 20 years of providing communications to support utilities, growth in SCADA, distribution automation, other OT/IT requirements before coming over to Ericsson as a utility sales director. And with that background, I would say that utility industry is changing at a warp speed, or at least, at utility warp speed. And usually I get a chuckle from the audience when I talk about utilities moving at warp speed, because we know historically things haven't changed very fast. But I know since I started with AEP back in 1988, the way utilities deliver energy has changed significantly, and the expectations of their customers has changed significantly. The conversation has gone from the migration of analog RS-232 interfaces to IP-based protocols, and the creation of NERC standards. In addition to the reliance on fixed wireless communications now being overtaken by wireless technologies. So the question is are utilities prepared to prevent and solve cyber attacks over the ever-changing technology? To answer this question, Ericsson engaged with Z-Prime to survey over 80 of the leading utilities to pose some of the questions about the status of network security, and within their organization, their utility. And the white paper provides the results and insights to those discussions, but I'm going to discuss some of the few findings that we found, but you can download the full paper at the above URL you see here on our slide, or you can go to the links on one of my posts that I had in LinkedIn. I've highlighted that a few times, and so you can go to one of those. But jumping into some of the findings here, so our very first slide is related to when does your organization plan to move to LTE or 5G networks? One of the key findings here is that this portion of the response is the anticipated growth of the cellular networks is by 36% of utilities within the next 5 years, while 17% are in the process of evaluating and moving forward. I find it a little concerning that 39% have no plans to move forward in a strategy. So I don't know what their, what is their strategy going to be to support the use cases that necessitates a private wireless networks that are sometimes best served by LTE 5G, how they're going to support that growing list. I remember back in 2011 timeframe when I started having a discussion with utilities about utilizing commercial cellular networks for replacement of the traditional copper wire connectivity. And it was received a lot of concern about reliability, security, and cost. But as you can see, a lot has changed with that perception over the last 10 years as technology has changed. But we'll see in the survey responses they're still in top of mind. Going to our next slide here. So on this one, what future value does your organization see in LTE 5G private networks? Why would you consider those networks? And improved connectivity is the leading driver for the deployment of LTE 5G, which will allow them to deploy the latest technology to support providing safe, secure, reliable networks, which supports the key fundamental expectations of utilities. And hopefully you saw that I use safe as the first driver. Utilities definitely want to do everything in a safe environment, and definitely the communication platform can help to enable that safe by giving real-time guidance into and insight into what's happening out in the field. So connectivity is top of mind so that you have more insight into the grid performance as your customers have increases in their expectations on the service you provide, and those are including the distributed energy resources and electric cars as we start to see a proliferation of electric car. And real-time guidance on what is happening is now not only a nice to have, but it's a essential requirement of the communications network. And then the next question we posed was, do you have the skills and tools in your organization to discover security threats and vulnerabilities in cellular private networks? So you're going to hear a lot more from Ken here in a few minutes, and he'll introduce himself. But in our white paper, we identified, and he'll talk about the 4 key pillars of network security. And they include 1, assessing possible avenues of attacks, assessing the likelihood of an attack, ability to discover the cybersecurity attack, and 4, understanding the impact of the attack. And as you can see from the survey that of the 80 utilities, over 60% are not sure they have the in-house resources to adequately address these 4 areas. 40% don't know if they have it. 22% realize that they do not have it. So a very high number that they've identified of challenges they may have. Next question is around what challenges do you have with your organization's current network security system? And so, as we mentioned in earlier slides, the driving need for LTE 5G is the growth of edge devices that help provide the safe, secure, reliable networks to support the utility core business. The number of edge devices is growing exponential, no slowdown in the near future. There's a lot of market research that's being done, and I'm seeing some, very large numbers being thrown out there for the number of edge devices, not only in the millions, but billions and tens of billions of devices it's going to be rolled out. So again, to piggyback on the previous question, second is the concern with enough internal talent to support the required network security. I think it's important to highlight out of this survey question that only 9% lack of executive buy-in. So that's pretty impressive that the executive teams at utilities, cybersecurity is top of mind for them, and they're helping to support it. They're helping to fund it, and as you guys are definitely aware of the fact that even our federal support is saying that cybersecurity for our critical infrastructure is a key component for making sure that we don't have significant impacts to that critical infrastructure. Next question: what potential security infrastructure challenges do you see regarding the integration of cellular networks into your existing IT/OT security system? So the biggest challenge for utilities when integrating cellular networks into existing IT systems, network security, or the data privacy, making sure your network is not hacked, and then that the data that is being provided through these new edge devices is not being captured and used for nefarious reasons. But regulatory requirements, 39% are impacting many areas of security, including NERC-CIP. For example, I read that in the U.S. federal government recently has banned electric utilities that supply critical defense facilities from importing certain parts from China. And I'm not sure if Ken's going to talk a bit about supply chain management, but that's another area that you're starting to hear conversations about from a cybersecurity, is making sure that the components that are being included in your infrastructure are controlled and tracked to make sure that they're providing the right level of security in the manufacturing process of them. Our key findings, just to kind of summarize here, is around, one is that 65% of respondents find that improved connectivity is the top value that LTE 5G can offer their business. Again, connectivity is going to be critical to making sure that the safe, secure, reliable network is managed and that you're able to provide the quality of service that utilities expect. When I was at the utility, primarily most of our customers expected that when they flipped the light switch on, the lights came on. I don't think that's the case anymore. They like to have many different expectations based on the electronics you have in your house, and again, the distributed energy resources and the electric cars. And then the second key finding here is around cybersecurity, resiliency, endpoint security are ranked the most important security solution by the majority of respondents. So definitely endpoints, we talked about the exponential growth of endpoints, then the security of that and the resilience of it. And then the part that is really most concerning, I guess, is 62% either don't know or don't believe they have the skills and tools in their organization to protect against cyber threats. So definitely there's an educational need there to make sure that each one of the utilities has the capabilities in-house or reaching out to a third party to make sure that they have a plan of action to address cybersecurity. But I want to end on this part before I hand it off to Ken about cellular networks and the way forward. Again, I was one of the early people who were advising utilities that cellular networks was a way to communicate over wireless infrastructure. And cellular networks have evolved to provide users with exceptional communications, ultra low latency, faster, more reliable connections. So those looks that I got, like I had, 4 eyes and 3 ears, they're now starting to be more accepting of the fact that wireless LTE technology, 5G technology is a way that they can use to provide a more secure, efficient, flexible connectivity. It's going to support the utilities modernization, digital transformation efforts, and their grid modernization. So now I want to hand it over to Ken. Ken's going to talk a little bit about some of the things that we at Ericsson are some recommendations, some areas of concern, some things that for you to look at. And with that, Ken, I'll turn it over to you. And if you don't mind, introduce yourself, give a little bit of your background, and I'll drive from here. So just let me know when you'll move to the next slide.
Okay. Thank you, Steve. So my name's Ken Kaminsky, and I am Ericsson's Director of Security for Private Networks. So those are the private cellular networks for North America. I came from a background, I worked for many years for Cisco Systems as one of their lead cybersecurity architects. And I did a lot of work with the utility space with companies like National Grid, and a lot of the others, especially up here on the Eastern Seaboard, where I was stationed here. So I've got a lot of background working for utilities, and that background that combines really the enterprise space along with the service provider or the cellular network space is one of the reasons why Ericsson brought me over about a year and a half ago. So next slide, Steve. When you're thinking about, cybersecurity, from a cellular networks perspective, on the utility side, you actually have 3 different cybersecurity models that are in play that you're kind of juggling these around with, figuring out where to use which one and when to use another. And those models are briefly on the cellular side. Everything comes out of an organization called 3GPP. And there are a lot of standards, both from the technical side on the cellular side and on the cybersecurity side that dictate how vendors actually build product to go into cellular networks. The 2 major standards there is a standard called TS 33401, and that's the LTE 4G side. And then there's another one called TS33501, which is the 5G security system architecture slide or system. And that actually, dictates all of the functions and cyber features that we as vendors like Ericsson will go ahead and use to build into the networks. Another one that's come up in recent years is a framework or a model called Zero Trust. And this is a very different way of thinking about security, and I'll show you that in some slides coming up. But it came out of the enterprise space with Forrester, which is a consulting organization. And very recently, NIST has actually standardized in a document called NIST 800-207. The federal government is very intent on implementing this across all their networks. Certain verticals like the Defense Department in particular are very far along, with this particular standard. Or actually, model or framework as a way of looking at security. And then the one that you're all familiar with is really NERC CIP, focused on the bulk electric system there, which has its security standards and ways of looking at things. Next slide. And in that, NERC CIP really has this idea of making sure that the OT side of the house is completely broken out from the IT side with a lot of security controls, in particular along those perimeters. So there's this concept of an electronic security perimeter or an ESP that all external connectivity has to go in and out. And then you're going in through this idea of an electronic access point, maybe something like a next-gen firewall. One kind of really key point here is these defenses are primarily north-south. So a lot of these cyber controls are things coming into the OT network or going out of the OT network from a north-south perspective. Not so much looking at a lot of the east-west traffic, where a lot of those devices and different applications are talking within the OT side of the house. And the idea here is that trust is based on your network location. So if I'm in this location, I'm going to go through one of these EAPs, and that's going to do a lot of my security controls in this type of an environment. And then, security breaches, often move from the IT to the OT side, and then they'll go ahead and move vertically in a lot of cases through the network at that point. But this is a very kind of north-south, kind of way of thinking of things. And it's an idea that trust is based on your network location. If that device is within a secure location there, then those controls as we're going in and out, will be applied. Next slide, Steve. And this is where Zero Trust really changes the game here. And Zero Trust is interesting, in this Z-Prime survey, we actually asked the utilities, how is your organization actually implementing Zero Trust? And as you can see, the majority of the folks out there are still looking into it. So this is still something that utilities are really looking at to provide in the future. And those that were, implementing it, were looking at, concepts that are important within Zero Trust. Like implementing micro-segmentation maybe in those OT networks, where I can look at that east-west traffic and put some controls in place instead of just the north-south. And there are some other ones around software-defined networks and then enhanced identity. Next slide. So what is Zero Trust? And it's really difficult to actually, explain this, but I'll give you a couple of the main ideas. So it's a model or framework that you apply, and it inherently assumes that the network is untrusted. In other words, it assumes that, some bad actor has already got inside the network and is actually operating there. So it really throws out this concept that security is based on the device location, because it's assuming that someone's already within the network and acting, in terms of malfeasance. It has these general ideas too, that every device, every user, and every application each one of those individually will be individually authenticated and authorized on a per session basis. It has an idea that everything that can be encrypted should be encrypted. So you want to look at encrypting every transaction and every flow. So encryption, across the board becomes a really important component to actually go ahead and implement. It looks at segmentation also in terms of macro and micro. And a very simple way to think of the difference between those is macro segmentation is really the way that you're doing it right now in OT networks, where you're doing controls often based on the IP subnet that I'm coming in and out of. A micro control would be able to do a control within that subnet. So within that subnet, normally the rules of IP networking allow everyone to talk to one another. But in this case, a micro-segmentation control would say, no, we're actually going to implement controls. So that specific device that's on the network cannot talk to another device within the same subnet. Another idea here is that everything is automated. So automation becomes huge because trying to implement a lot of these in the size of the networks that we're dealing with, the manual controls are just not possible. So automation becomes a critical thing to actually implement. The fifth major point that I've got here is that policies need to be dynamic and calculated from as many data sources as possible. So that, for instance, when a device comes on the network, it will be authenticated, and then other pieces of information about that device would be considered. Like, is that device running vulnerable software? Where is that device in terms of its location? Who's the user that's located on that device, if there is actually a user that's associated with the device. And all of those different things would be considered in that authentication decision. So if it's running vulnerable software, maybe we would want to patch that before we'd allow that to come onto the network for the first time. And then lastly, everything is logged, and complete visibility is very important in this security model. So you're getting logs from all the devices, you're processing that, and you're looking at other pieces of data like network flow data, who's talking to who. And we're looking at that data so that we know who's talking to who, and we know also what's normal on a network, so we can baseline, well, this is normal connection activity, for this part of the electrical grid, and then we could flag behaviors that are not normal that might be going on then. So again, this is a completely different way of looking at the network, and it's a different model or a different framework. Next slide, Steve. And the way that I usually encourage utility customers to think about it is, think about if you're doing a new project, maybe a smart grid device or a metering, if you're doing a metering project, for instance. So look at the devices that are out there, and the vendors in this space have been putting some really great security controls and features in these devices. So they have devices based on PKI certificates. They have application level encryption that these devices can do in talking with the applications coming back, so that they're only talking to the applications that they should be within the data center or the cloud data center, and all of those devices are authenticated and encrypted. So, and that's generally a way to look at zero trust also, is that this is not an all or nothing event. Everyone that's implementing this is implementing this in stages, because it's such a different way of looking at security. So people will take a project here or a project there and say, how can we look at and implement these principles, and just do it from that project perspective. Next slide, Steve. That gets us into this third security model, which is 3GPP. And cellular networks is not something that we've found that folks are familiar with across the board. So let me just kind of explain a couple of just basic ideas here, and then I'll get into some of the security controls. So the basic idea is moving from the left side of the slide over to the right. We have a device, and that device has a SIM card in it, and that SIM card has the actual security keys in a piece of hardware that's very, very difficult to get into. And that's where the security controls or that key is actually located. That device will talk over the air to RAN nodes or radio access nodes. In 3GPP terminology, in 4G, we call that an E node B. And in 5G, we call that a G node B. That's just the radios and the baseband device that's actually taking all that radio communications and basically converting that into IP packets that come out the back end. So as we go out of those nodes there, those connect to a transport network in the utility network. That is generally an MPLS backbone that runs IP. And that's the transport network side of the equation there. And if that is untrusted, we're going to run IPsec as a security control in order to go across the untrusted portion of the network. If it's trusted, then it will run unencrypted. Those connections then go back to the core network, and that core, all that is a data center or a cloud type environment that is running applications in a Kubernetes format. So those are like Linux containers that all of the network core functions are running on. And all of those Kubernetes containers talk to one another, and the different functions that the cellular network uses, and there's a bunch of these, are called network functions. That's the term that we use. And those all talk to one another within that core network. And then we leave the network, going back into the enterprise backbone over on the right-hand side. So that's kind of just a big picture of it. Let me just talk about some of the controls in a little bit more depth. You can go to the next slide, Steve. I'm going to talk about the end device for a moment here. And the security, like I was saying, is in the SIM card. And that could be a SIM or an eSIM, where the actual hardware component is just built into the network card, or the actual card that the device has there. And there's a main key that's there that actually controls the security of that. And that key there is protected, within that piece of hardware. It's very difficult to get it out of there. The keys that are actually used are coordinated with a protocol that runs out of the cellular core, and it's a variant of EAP that's very familiar to people that are in enterprise communications. But the cellular variant of this is called EAP AKA, and that's how we're exchanging the keys and we're authenticating the device, onto the network using that. There are controls in place in the cellular network, if you're using them, to make sure that that SIM card or that SIM is only used by that one device. So it's actually going to coordinate two pieces of data. This piece of data we call an IMEI, which is the actual device ID. And then there's something called an IMSI or an IMSI, which is a 4G term, or a SUPI, which is a 5G term for the same thing. It's the user or the subscriber ID, and it ties those together so that if someone, grabbed that SIM, if it was removable from the device, you can't just remove it to another device and connect to the network, because these controls are in place, and that would be flagged as not allowed. Now, a major difference here between service providers and private networks, like on the utility side, is this, and it's kind of a fundamental difference in way to think about the end device. The service providers in a traditional cellular network don't really care too much about the end device at all. They just care about that SIM card. That's it. They don't care about the applications that are running on it. They don't care about the device itself, because you're just buying a service from them. And they only care about just that SIM piece. That's very different. If I'm a utility and I'm running a private network, I care very much about that end device. And I want to have security controls built in for that end device also. So, traditionally, if that device is something like a smartphone or a tablet, I would use, controls from these vendors called mobile device management or enterprise mobility management vendors. Folks like Mobile Iron or VMware AirWatch, IBM's Mass 360. I'd put the agent on there, and then I would use that to control the security controls and a whole bunch of other things that are going on in that device. So I would use that. Just go back to the previous slide there, Steve. So that's one major difference between the private and the cellular side of the house there. Now, some other controls we have within the cellular network is there's very good encryption and integrity that actually happens over the air from the device going to the radio access nodes that are there. So we have encryption, which is encrypting the actual traffic using very strong AES level protocols. And then we also have integrity features, data integrity features, also using AES. And the difference between encryption and integrity is that with encryption, I'm hiding the data. With integrity, what I'm doing is I'm making sure that every bit that went over the air and got to the other side, got to that side exactly in the same sequence that I wanted it to get there. There's no changes, no one maliciously changed it or even accidentally changed it, maybe with a burst of interference. Everything made it that was supposed to go from one end of the network to the other. And those controls are based on AES protocols. So very strong protocols there. And then there's there's really two control planes here when you're thinking about a cellular network. There's a signaling control plane that's handling the connection setup, and there's very strong encryption and integrity controls there. And then there's the actual user plane, where the actual user data is moving, and we have strong controls there also. So that's what's going on over the air in terms of the air interface there. And then the packets will go ahead and get dumped out onto the internal transport network. Again, that's generally MPLS in a utility network. We will encrypt that if it's untrusted. We'll leave it unencrypted if it's not. And then it will hit the actual core network itself there. And then you see those little yellow boxes there called security gateways. Within the 3GPP way of looking at things, we call a next-gen firewall a security gateway. Utilities call it a next-gen firewall, but it's really the same thing, and it's the same vendors that will actually provide that, be it Juniper or Palo Alto or whoever else is out there. There's just some features that are built into those boxes that are related specifically to certain protocols that are running on IP that are related to the cellular network, and I'll explain those later. So in a lot of cases, we'll put a security gateway sometimes in front of the core, and then we'll want to have one a lot of times behind the core if you're actually managing security controls from a next-gen firewall feature functionality going into the cellular network, going into the actual core itself. Next slide. And then go one more here. And I'll just get into a little of the logging architecture that comes into play here. It's just another way of kind of looking at that same diagram that I showed you. So I've got my radio nodes over on the right, and I have different pieces of cellular networking gear that are reporting security-related events here. So I got my radio nodes, I've got my security gateways, my next-gen firewalls at different points, and then I have my core network functions that are reporting security events. And traditionally in a utilities network, we're going to send those directly to the SEM over in the upper right. And a lot of times that's Splunk, that seems to be the dominant vendor out there, but there's a number of other vendors that provide that SEM functionality where the intrusion analysts or the incident response analysts within the SOC are looking at that as kind of one of their primary vectors in order to figure out if there are any penetrations that have happened within the network. The main difference here with that model is the SEMs were really built with IT networks in mind and for IT use cases. There are use cases on the cellular side that don't fall within that. You know, processing that OAM network data or the OAM data for the maintenance side of the house for all of these devices and looking at that in tandem, that's a specific use case. Looking for things like false base stations is another specific use case that's out there. So in a lot of cases, you may have a product like the Ericsson Security Manager that is actually grabbing all of those logs and processing those from a threat vector standpoint, and then sending that processed data onto the SOC where the utility SOC is located. So that's kind of a general idea that's here. Also within this system, there's a full PKI or certificate-based system so that all of the communications, if I'm doing this from an OAM maintenance perspective, all of those communications are protected with certificate-based authentication, and all of the communications between the different devices within the cellular network are also protected with PKI certificate-based authentication. Next slide, Steve. And that the Ericsson Security Manager, it's doing those threat-based detection use cases that I just mentioned. But another thing that it actually does is it does security compliance or configuration compliance. And this is automating things, you know, like with SIP 10, the config change management features there. That can be a manual process where you're going and looking at it. And these types of products on the cellular side can actually automate that for you. So it'll look at the security configurations of everything across the cellular network and make sure that nothing's changed. And if there were any changes, it can automate that configuration in order to make that an automated control rather than a manual one. So that's what these types of pieces of technology are actually doing, like ESM. They're processing the configuration data to remove the manual side of the equation, and then they're automating a lot of these threat use cases that are not handled by a traditional SEM. Next slide, please. Just a little bit more on the transport side here and what's actually going on. So what's actually going on across the transport is there's three things that are happening there potentially, two definitely, and a third possibly. We have segmentation that's going on. We have encryption and integrity that's actually going on there via IPsec, if it's actually untrusted transport that's there. And we may have next-gen firewall features that are running there either in front of the core or behind the core going out into the actual utility network on the backside. So we're doing segmentation through a number of mechanisms here. On the actual radio baseband, we're using virtual routers, and those virtual routers will map into the MPLS technology that's being run on that backbone. And a lot of times MPLS has MPLS VPN functionality where that virtual router will map directly into that. And in that way, the MPLS network will keep the OAM network completely separate from the RAN network where the control plane and the user plane data are actually running out of. And across this environment, we absolutely want to have those two completely separate. Never the two shall mix. And we'll use that type of technology and feature functionality in order to do that. If it's actually untrusted backhaul there, going across that, we'll go ahead and encrypt it. And if we're looking for next-gen firewall features, things like anti-malware or intrusion protection systems there, we can run those on those next-gen firewalls that are running there in front of the core. Next slide, please. On the OAM side of the equation, there's a lot of security features that are actually run here in order to protect this. So there's usually a management system that's configuring all of these devices within the network that's really running that OAM network that's there. And within that system, there is the ability to do centralized authentication and authorization, maybe back to an Active Directory system, or using an LDAP, a secure LDAP store that's there. All of these are based on PKI certificates for the highest level of security. There are role-based access controls for all of those accounts that are built into that. And then all of these protocols that run are always run in an encrypted format. And depending on whether we're doing performance management or fault management or configuration management, those protocols are different. They could be netconf using SSH or TLS. They could be SNMP version 3 or secure FTP, depending on which one of those we're actually using it for. And then, of course, we're logging everything from a security perspective. Next slide. When we look at these security gateways, whether it's in front of the core or behind the core, again, these are just next-gen firewalls. In the actual example I'm using a Juniper slide here, but Palo Alto firewalls work just as well and have all of the same similar features that I'm about to talk about here. So I'm just using Juniper as an example, but Palo Alto is also, completely a good choice. And they're also a very good vendor who's used often, in particular within the utility networks. So these are again next-gen firewalls. They could be hardware-based, depending, or they could be software-based, depending on how you actually want to go ahead and deploy that. Next slide. And the main thing, I alluded to this earlier, what makes this next-gen firewall used in this cellular, kind of function here, different from what you're doing normally over on the on your enterprise network? And the answer to that is there are a couple of protocols that are different in the cellular network. Everything does run on IP, just like you're used to. But on the control plane, instead of TCP, we're running a different protocol there. It's called Streaming Control Transmission Protocol. And that has a lot more high availability features that are required, versus TCP. So that's on the control plane side. On the user plane side, we're actually running a protocol there at layer 4 called GPRS Tunneling Protocol, or GTP. And these protocols really grew up in the cellular network, in particular in 4G networks, when a lot of these, became very popular. But that's the main difference. And with using these layer 4 protocols, that Juniper SRX or that Palo Alto firewall understand these particular protocols, and they can actually do a lot of intelligent features to actually help secure those and to look into those. So that's the main difference there. It's still all IP, but we have some different protocols running on top of that. Next slide. And then, a lot of times you'll want to, with these next-gen firewalls, because this is running in an enterprise environment, you're going to actually go ahead and potentially run, higher level services there. And that can be done, on these firewalls, just like you're doing on the enterprise side. So some of the more popular ones that I see are things like application visibility and control, intrusion prevention, some of the botnets and command and control, maybe potentially on the threat intel side. Certain of these, make sense. Certain of them do not, potentially. So if it's an IoT network out there, the web content filtering, or the anti-spam feature functionality, that wouldn't make sense on the cellular side. Whereas that would, on certain points on the utility enterprise side. But these are just next-gen firewalls, and you can go ahead and stack these features depending on which ones you want, and you can mix and match those. Next slide, please. Just a little bit about the core here. So remember, the core is just a whole bunch of applications running in a Kubernetes environment, running Kubernetes containers. And they look different from a security standpoint from the security features that 3GPP built in. So if I'm dealing with 4G, and in the utility networks right now, it's 4G networks that we're building, mainly from a device side of the equation, because a lot of the devices don't have the 5G interfaces just yet. They're all kind of coming, but the 4G side of the equation is completely built out. So a lot of the cores that we're building and deploying right now, we're putting them in, with the 4G network functions, with the ability to go to 5G whenever you want those by just turning that software on. In a 4G architecture, the protocol that's often used here is called diameter. And that's a variant of the radius protocol that you're familiar with on the enterprise side from a security standpoint. And that's used. We're assuming a secure location in a 4G architecture. In other words, that this is secure because the communications between those network functions inside of the core, that's assumed to be secure, so they're not encrypted. And that's very different on a 5G side of the house. So the 5G took a lot of those zero trust principles, that we chatted about, and they implemented, some of those within a 5G core. And the difference here is those different network functions that are doing all of these different kind of signaling control functionality here, they have the ability to configure those where they can use basic standard REST-based APIs using HTTP2. So when one network function is talking to another, it's using those REST-based APIs. They're going to use TLS encryption, and they're going to use PKI-based certificates. And they're going to actually use a standard called OAuth 2.0 to basically authorize the communications between one to another. So if one network function wants to talk to another, he basically gets permission to do so using OAuth 2.0, and then he's going to encrypt all of that using TLS encryption and PKI certificates. So it's a real secure architecture for all of these different software components to talk one to another, using these types of zero trust principles that was built into this by 3GPP. Next slide, please. Another, piece of this equation is, in these networks that we're building out right now as Ericsson, in a lot of cases, there's this desire to roam with a particular roaming partner. So you're going to exit that cellular core, and then you're going to want to chat with one of the mobile network operators that are out there so that your users and your devices can actually roam from one to another. In order to do that, there is another piece of software that sits on the edge of the core that actually controls that functionality. And this is called, within the actual 3GPP kind of way of looking at things, it's different between 4G and 5G. So in 4G, we use this thing called a diameter edge agent, which is, in that middle box that's down there. And if it's 5G, we use this thing called a security edge protection proxy. And all these things think of these, from an enterprise perspective, these are really application level firewalls. And these firewalls understand the particular communication protocols that's going on the roaming network there. So they understand diameter from a 4G perspective, and from a 5G perspective, they understand HTTP and REST API and how those things are actually put together. And that function, within the Ericsson product line, we call this a unified signaling firewall that exists in something called our signaling controller, which is a software product that we would deploy in order to use this, this type of functionality. The big difference here, with a utility network, versus a mobile network operator, a mobile network operator talks to a lot of other operators out there. There's a lot of communication that goes back and forth in order to roam from one network to another. In a classic utility private network, there's usually just one of those. So maybe one partner that you would pick, one of the major mobile network operators, and that one would be the one you're going to talk to, out across this interface. And what I'm kind of conveying here is there are software features that you can use here if you want this additional level of security. And this is really just the best way to think about this is, again, think about this as an application level firewall that understands these particular protocols, and it's doing a lot of things there in order to make sure that all of those roaming connections are good and valid, and there's nothing, coming across there from a fraud standpoint. And then the last slide. A lot of times we get the request in order to use probing vendors, folks like NetScout and the others that are out there. And they say, okay, Ericsson, we want to go ahead and tap your core because there's a lot of really useful information that's flowing back and forth. And we want to use these data flows in order to basically correlate information and get a lot more information as to what's going on within that actual core, whether it's 4G or 5G. And that presents a problem in a modern core that's running a Kubernetes container-based environment. Because if you know anything about Kubernetes, these are just software containers that are spinning up for these network functions, and they can spin up on any hardware platform that's used underlying. And if I wanted to tap that, through a virtual switch port on that underlying hardware, that can be very, very difficult to do in this environment because those containers could exist on lots of different hardware platforms in that core. And then if I'm in a 5G environment where I have that extra security, that's an encrypted stream. And my probing vendor can't read that. So the solution to that is to actually use this thing called a software probe. And think of this as just another software function that we built into the software that's running on those containers. And what it will actually do is it will spit out a stream of packets in the exact format that these vendors want, which is usually a PCAP format. And it will build, the right series of headers that are required in order to make that look like a normal network packet. And it needs to do that because this isn't a normal network packet. This is one container talking to another. There's nothing going on down here at the lower levels. So it'll construct these packets in a format that those vendors need in order to process, and then it will send that out in a stream in order to do it. So if that's something that you want to do, and we have had utility customers that have specifically asked for this, then this is something that would want to design into the core to be able to do this for you, upon request. And that's the last slide that I got here. I wanted to, finish about 5 minutes early. So we timed that good, Steve. I think at this point, is there any questions? It was a little bit of a fire hose that I gave you there.
You did a great job, Ken. We do have a question. I think you've got time to answer it. You alluded to some of it, but I'm going to read it straight out as it's typed in, and
Okay.
maybe you can just talk a little bit more about this. So the question is, for zero trust authentication, do you see device, user, and application authentication all software based? And the follow-on to that is, how do you see cellular modules helping to provide network security?
Yeah, that's a really good question. And, I'll answer it in terms of, the products that you would use in a regular enterprise to do that. You would use an identity engine to do it on the network side. If I'm coming off like the wired side or the wireless or maybe a VPN connection, and that would often handle the user and the user on the device. And then on the application side, there's all sorts of application kind of software that you'd use there in order on an application by application basis to kind of manage that. So on the enterprise side, you kind of had those two ways of looking at it. On the cellular side, the cellular network can help with that because it will authenticate the actual device. So the device comes on the network, the SIM that's on there will do an authentication that's there. From a zero trust standpoint, then you ask the question, well, what about the application that's running on the device? And that would be dependent on the application itself that's back within the actual utility data center. I gave an example of that, like a modern utility metering kind of a project that you might be looking at. Look for those features, because those vendors, like the Itrons of the world and the others, they understand where this is coming from, and that would be a good thing to look at to see if those features are there. And they're providing that. I was at Distributech just recently, kind of chatting with them all, and there's a lot of that feature functionality that they're building into it and doing a real good job with that.
Great,
I
thank
think
you.
I hope that answered the question.
Yeah, I think so. We had one more come in. I think we've still got a minute. Are you concerned about PKI-based security in light of future quantum computing threats?
Yeah, that's a good question. And the answer to that is yes. There are features and functionalities depending, there's a little complexity to the cellular network, like I showed you. Certain pieces of that already have algorithms built in there that are already good for that. Other pieces, what everyone's waiting on, in particular for what's called asymmetric cryptography, kind of RSA-based crypto systems, what everyone's waiting for in the industry is for NIST to complete their work. And they've gone through a number of rounds with that. With certain types of cryptography, we already know how to deal with that problem, and some of that is already built into the cellular network. With other pieces, we're still waiting on NIST, and a lot of folks are waiting on NIST to get through that process, where they're going to standardize on certain algorithms like they did with AES. And once they do that, everyone will fall into line and kind of solve that piece of the puzzle.
Brilliant, Ken. Thank you for that. We are right at the top of the hour almost. Any last comments, Steve or Ken?
Nothing from me. Thanks. Appreciate it. Enjoyed it. Ken did a super job as usual, and excited to follow up with any of you that might have questions. Reach out. We'll be glad to continue the conversation.
Great. Thank you so much. I do want to also let our audience know July 12th will be the next webinar in this series, and we'll be sending out the information and the registration link in the next day or two. So just sort of earmark your calendar for July 12th, and we'll continue the conversation. Of course, UBBA is always continuing this conversation. We have a cyber and technology working group that focuses on these topics on ongoing basis. So if you're not already a member, please do reach out about membership. And just a quick plug about October, the week of October 10th, the UBBA Summit and Plugfest. If you go to ubbaplugfest.org, you can see the information. And again, we will be having some of these same discussions there in person as we continue the conversation. And certainly Ken and Steve, we appreciate your insights, great content for this one. And of course, we appreciate Ericsson's membership and leadership in the area. So, Thank you for everything. We'll close off for now, and I hope everyone has a great rest of your day. Thanks, everybody.
Thanks.
Thanks. Take care, everyone.